Okay, to begin with today's topic, that is interior of Earth, let me start with a theory. And I hope every one of you have studied that theory in your early classes. What is that theory? That Earth is divided in three layers. Outer layer is Sial, then Sima, then Nife. Most interior part of the Earth is Nife. So what earlier theories said that Earth is made up of three layers. Outermost layer made up of silicon and aluminium, and the middle layer is made up of silicon or silicates and magnesium, and the core of the earth which is made up of nickel and iron. So this theory, let me tell you, is obsolete now, and we are not going to talk anything about this theory. The only relevancy of telling this theory is that you are not going to use it anywhere in your studies or your answer writing in UPSC or in any other exams. If you are pursuing masters or bachelors where this theory is taught to you, you can write about that, but at least not in geography. And if I'm being very precise, then in GS geography. Optional, it might be there, but since we are not covering optional, so I'll exclude that. Now, if this theory is irrelevant, what is the correct theory? Okay, so we shall come to correct theory, and let me take a cross section of Earth. If I say this is Earth, and I take this part. This is the center of Earth, and I take this part. This part has become large here. I have taken this section. 3R, interior of Earth. The topmost layer is called crust. Below the crust, the layer which is not is mantle. The most interior part of the Earth is core. Okay, and there are subsection also there in it. Like the core is divided in outer core and inner core. Let's say it is outer core. This is inner core. Mantle is mantle only. Crust is divided in outer crust, inner crust. Mantle is also divided into two layers, different color. Is upper mantle. This is lower mantle. Okay. So these are layers which are there in the interior of Earth. Now, is this enough? No, this is not enough. This is the beginning point, or what I say, ABCD of the topic which we are going to study. Now, before I begin with the topic, let me tell you why do we even study this topic? Why do we study interiors of Earth? Our subject is geography, and geography is concerned with most of the times features the surface of Earth. Then what is the need of studying interior part of the Earth? So let me be precise. We are not going to study very deep about the interior of Earth. It's superficial. Okay, maximum 1 hour lecture, and basically it is part of the geology. But since it is covered in your syllabus, whatever is there in the syllabus, we have to cover that. But the logical argument is, this is not the logical argument. Why it is covered in the syllabus? It might be a logical argument. And what is that logical answer of that? That there are many phenomena which you study in geography, like plate tectonics, then the color, Apart from plate tectonics, volcanism. What next? Uh, Mountain building. What more next? Earthquake. And very interestingly, magnetism. Many more phenomena like erosion, and there are many others apart from these. So all of these phenomena or the forces which we study in geography are somewhere directly or indirectly are related to interior of Earth. Therefore, it is necessary for us to study interior of Earth. Okay. So I won't waste time. We shall cover all these in our coming slides. But before that, we shall cover this. What is interior of Earth? So we have studied that the outermost part is crust. So every solid has its own density. And since there are different layers in Earth, so there will be different density of layer. It's very obvious, very scientific. No need to worry about it. And it is not at all rocket science. So average density of Earth is around 5.51 gram per cent. Okay, it is around, not precise figure. Now when we come to the core, or sorry, not core, but the crust, the density of crust is around 2.7. Its density is lower than the average of Earth. Since its density is lower than average of Earth, it is the topmost layer. You can say when Earth was building or Earth was forming, everything was in either in gaseous state or in liquid state, and we all know whether in gas or in liquid, or precisely in fluids, the denser part sets down, the lighter part sets above. Therefore, the crust is made up of the lighter part. That's why its density is relatively low, the average density, and very low than the core part, mental part. So, what I shall do, I shall crust only. And we all know it is the outermost part of the earth, and there are many relief features on the surface of the earth. What are these relief features? Like I say, oceans, continents, mountains. Okay, I have tried to cover very large relief features. It will be different. Like there will be ocean here, mountain here, and continent here. Let me try it. For ocean, I'll take blue color. For mountain, I'll take black color. Okay, so this is the crust. What I'm trying to tell you is the depth of the crust or thickness of the crust will be different on every point of the earth. It might be around 70 kilometer of depth of thickness on continental boundary. It might be around 7 to 30 kilometer of thickness ocean boundary basin. It may reach up to 100 kilometer on tall mountains or on mountains. Not being precise on each part, telling you the general characteristics. Okay. So the thickness will be different from different points. What is the reason of this thickness? We all know that since oceans are quite deep, so the space is filled with the water will not be covered in the crust thickness. Mountains are elevated part, and the distance or the thickness or the depth will be covered in the crust part. It is very simple. Now we have already covered this one. We have already covered the depth will be different from different points. Now, meant material. So the main constituent material in crust is, for your surprise, is oxygen. The second most abundant material is silicon. Now, if I talk in the perspective of earth, the most abundant material is in the earth is iron. Remember my point, it is in earth. And this one is in crust, also in mental, but stick to the crust only. Oxygen is most abundant material in crust, while when I talk in the perspective of entire earth, it is iron. And this question has been asked in either Rajasthan state administrative exam or some other state administrative exam. I remember it clearly, but I mean, obviously I don't remember the exam name, but it has been asked. So there is a data for you to remember it. Now, look, the crust, since we all know the crust is topmost layer, and every external force will work on the crust, and its impact will be seen here only. This impact, what this has been done, this has been made crust into different layer. The topmost layer of crust is made up of sedimentary material. All know what are sedimentary materials. Sedimentary material is any material which is the result of erosion and accumulation process, and deposition process. So whenever we walk on sand, what is sand? Sand is the result of erosion. So the topmost layer of the crust is made up of sedimentary material. Below that sedimentary material found igneous rocks, which are usually acidic in nature. And below these igneous rocks, the rocks are basaltic, that is basic. If I summarize, crust has both acidic rocks, basic rocks, while the top part of it is the sedimentary deposition. The depth or thickness of this part is not much. It might be around 20 to 30 kilometers. This is, yeah. Now when, okay, so what I shall do, probably you have heard about discontinuities. We shall cover it later. It is better not to talk about them here only. Now, what comes after crust? One more name is there, that is lithosphere. You'll hear this name again and again when you study plate tectonics. And what is the definition of plates or earthen plates? These are the lithospheric slabs. This is the definition of plate. We are not going to cover what plate is, what is its definition. We are going to what this means. Lithosphere is crust plus upper part of mantle. Upper part of mantle. What is mantle? Mantle is the second layer of Earth. So this upper part of mantle, not entire upper mantle, but some part of it, along with the crust, which floats on asthenosphere. That floats on that floats on asthenosphere called lithosphere. You'll understand this, not a big deal. Now, the objective of coming on lithosphere is what is asthenosphere, to understand the asthenosphere. Okay, so we have covered the crust. Now let's come to the side, the mantle. Let me draw here part of mantle. So asthenosphere is partially molten layer. Asthenosphere is partially molten layer of rocks which is beneath the crust. Now, what is the logic behind this layer being molten? So, I forgot to tell you is about the temperature we the temperature, this limit of the crust, or I shall say the lowest layer of the crust, lowest part of the crust is around 400 degrees Celsius. All of us had heard about depth rate, temperature depth rate. Is it when we go above or to the height in troposphere, the temperature falls. What is the degree of fall? It is 6.5 degree decline with per kilometer height. Am I wrong? Am I correct? When we go a height of 1 kilometer, temperature decreases by 6.5 degree. This is called temperature lapse rate. Contrary to that, when we go down in the crust, when we go down in the crust, temperature increases. So therefore, when we go to the lowest layer of the crust, the temperature is around 400 degrees Celsius. Or if we go to certain more depth, it might be 700 degrees Celsius. So that is a range. Since nobody has ever drilled Earth to this level, so we cannot say the precise, cannot estimate the precise or calculate the precise temperature. What is the maximum depth which we have drilled the Earth is around 12.5 kilometers. So if I say on my observational ground, what I have seen with my eyes is maximum of up to 12.5 kilometer depth, not beyond that. Everything beyond that is based on theories, calculations, many evidences, which we shall study on coming slides. I was about to tell this temperature, and we shall notice part of asthenosphere. If temperature is if 700 degrees Celsius, at that temperature it is not possible for silicon melt down. So the temperature is definitely higher than 700 degrees Celsius. And what could be the range of temperature here? The range is around 1200 degrees Celsius, 1500 degrees Celsius. Now, what is so specific about this layer? The temperature is increasing so rapidly that, spite of being in our calculated range, which is okay. If I see this is not correctly visible to you, I shall change the different color. Is 700 degrees. What is happening here? The temperature on being 700 degrees Celsius became 1200 degrees Celsius. So the theories are given that there might be radioactive material might be here or present here. Radioactive material for calculation uranium. Since we all know radioactivity is a phenomena where a material decays without any external force or external reaction, and what it produces energy. Energy is converted into heat, and what heat does, it rises the temperature. So we are estimating, or we are seeing, or we are calculating, sorry, not we are calculating, we are propounding a theory that there might be radioactive presence in this part of the layer, only in this part of the layer, and it generated so much heat that rocks rocks went into partially molten state. And it is this state only on which lithosphere is floating. And why lithosphere is floating on that one? Because it is in the partial liquid state. If something is in liquid state, density is much higher. We have studied that density of the crust was 2.7. Here density changes from 2.9 to 3.3. Definitely density is much more. It will sink. This part will stay beneath the crust. The crust is lighter. This part is in liquid state. So sorry, not crust, but the lithosphere floats over it. And by the movement of lithosphere, we see plate movement. What these plate movements cause many phenomena studied, or we did down here. It is the result of volcanism. Volcanic material or lava, which we say, is material from asthenosphere. Mountain building process. When you'll study mountain building, you'll study different type of mountains, where mountains are the result of collision of two plates. That mountain building process is the result of plate tectonics, and plate tectonics is result of asthenosphere. Then earthquake. Whenever there is a tremor felt in earth, it generates earthquake. It is result of it, and these are not result of it. After that, entire part is upper mantle, lower mantle. One more thing I would like to tell you, that this part, lower mantle, is, though it is solid, but it is ductile. And why it is ductile? Because definitely due to its composition, here we find silicon with magnesium, it has become ductile. And this process, what is ductile mean? What does ductile mean? Ductiles mean something which can be bent down, can be deshaped easily. So if temperature is higher, material is ductile, heat is there, because temperature which was there around 700 degree, the lower part of the crust becomes around 400 degrees Celsius here. Okay. There is a immense gap in the temperature, or what would I say, immense rise in the temperature. When we go down here, so temperature is high, heat is And why it is high? Because energy is converted into heat, and heat, what heat is doing is rising the temperature. So what it shall do, it shall impact the material here in the lower mantle, and what it will do, it will cause this material to rise. Okay, not always, but many times. Whenever there is excess heat which the material cannot tolerate, so it will expand and it will hit asthenosphere. Since asthenosphere is partially molten, whenever this material hits asthenosphere will cause a movement in lithosphere, and it is the force which is causing plates to move, and we shall simply say it is the convection currents lower mantle that causes plate movement. Now here you'll find an answer of your questions, that why asthenosphere is in partially molten state. Okay, not that one, but why plates even move, why they are not stable. This is the answer. And after that, the most part is the core. Is the core. There are two parts in the core. Is outer core, inner core. Composition is almost same for both, but state of matter is different. This one is liquid state, while this one is in solid state. And what is the composition? The iron, nickel, or heavy metals. Now let me guys once again. Nobody has drilled so much down the radius of the earth. It is around, it is from 9,000 of depth to base of earth 378 kilometers. So the extension, the core part of the earth is from 2900 kilometer to the center of earth, which is six- around this at equator, and some less and some less at poles. So if nobody has drilled to this part, whatever we say is based on theories, and our theories are observations on different indirect sources, tells us that this part is in liquid state, this part is in solid state, and it is being made up of these materials. When we talk about of density of this part varies from 12.13 gram. Clearly see how dense material is here. It is very dense. The density was 2.2 the crust, and here it is 13. Now temperature, if I talk of temperature, temperature is from 4000 degrees Celsius, here 6000 degrees Celsius. Again, here temperature is enough to melt down a rock, and we can understand, since temperature is enough, depth is enough, heat is enough, this part might be or shall certainly be in the liquid state. But why this part is in the solid state, when everything which is required to melt a material is present here and is being resulted? But why the phenomena is contrasting here? And your answer to this point is pressure. All know, when pressure is exerted on a point, when pressure increases, When pressure increases, melting point of the rocks also increases. Now, at this depth, if you'll see the entire, almost the entire Earth is exerting pressure on this part. If Earth is exerting pressure on this part, the pressure has become very high. The pressure has become so high that instead of being in the liquid state, that part has become solid. And you might study different books where you will find different theories, like Savinder Singh, which is a very relevant book or very authenticate book, and that says no, it is not the concept. Probably this part is being made up of such materials which tend to be the solid state even at this temperature. So it might be true, but the only excuse we can see here, or the only logic we can develop as of now here, is the pressure theory. And for being Savinder Singh or any other book which support that theory, which corroborate that theory, that this material is made up of this part is made up of such materials which tend to live in the solid state even at this temperature. We need either to drill to this part, or we need further, I mean, they need to provide further solid evidences support their theory. As of now, since we are not doing PhD, shall stick to this part only, or to this logic only. Okay. Now, if this part is in the liquid state, if outer core liquid state, how does that impact any phenomena on the surface of the earth? Now, let's draw earth, then put in drawing part of geography, then draw the magnetic field along like that only. Now let us understand, since this part is in the liquid state, let me draw only the outer core, and it is only in the liquid state. It is made up of iron. So if something is in the liquid state, temperature is very high, what shall happen? Iron will Iron which is in the liquid state will tend to move from this part to this part, something like that. And in this situation, what shall happen? This moving iron will generate a magnetic field around the earth, and this is the magnetic field of the earth. It is the result of outer core. Okay, so you must remember this thing, must know this thing. Like, let me tell you, geography is science only. Either you study science or you study geography. Both are same. There might be phenomena, cannot say why it is happening, but there shall be certain reasoning, certain solid and scientific reasoning behind that. It is not something theory like someone said that and we believed on that. He has to prove that. And since geography is science, we need to have solid scientific evidence. And this is the scientific evidence can draw right now or at this time. Like, what is the reason of magnetic field of Earth? The reason is iron is in the melting state, tends to move the outer core, and move iron generates magnetic field. And this magnetic field is very important for us, protect us from what? Solar storms, solar flares. Due to this magnetic field only, certain climatic phenomena like northern lights, if I'm not wrong, there was a question either this years of mains or in the previous years of mains on the northern lights, but it was not related to this part. It was related to climatic part or the outer part, atmospheric part. Again, we have covered this. Now you must ask me, like, sir, you have told there are three parts in the interior of Earth. One is crust, okay. One is mantle. Another one is core. Then you went again and told us subclassification. This is outer core. This is this is outer crust. This is crust. Then upper mantle, lower mantle, then outer core, inner core. So how do you know this? How did you draw this inference like this is outer crust, this is inner crust, this is upper mantle, this is lower mantle? The simple answer is there is change in density. Whenever there is a significant change in density, we term it different layer. Like if the density remains under 2.7 to 2.9, we shall call it crust. The density remains from 2.9 to 3.3, we shall call it mantle. If the density varies from 12.2 to 13, we shall call it inner core. So this is the main basis of our main foundation of our inference on this part. Now, how do we say that the density is changing here? So when we study certain phenomena, we found that like there is a change in density. And whenever there is a solid change or rapid change in density, we call it discontinuity. We call it discontinuity. Discontinuity simply means when we are going from one layer to another layer, there is a change in density, and that part, that part where density is suddenly changing or rapidly changing, we call it discontinuity. So how many discontinuities are there in Earth? What if I say, draw it again, draw it again for you, and say back here. Okay, different color there. This crust, this mantle. When we go from crust to mantle, when we go from crust to mantle, we encounter a discontinuity, and it is given the name of Mohoro Vichich discontinuity. Mohoro Vichich or Mohoro Vicious discontinuity. When we go from mantle core, when we go from mantle to core, this discontinuity, his name is Gutenberg. This is Gutenberg discontinuity. This is Mohorovic discontinuity. Now your question, you should ask question to your teacher or to me or yourself also. Okay, this is fine. Say when we go from crust to mantle, we shall encounter discontinuity, and you gave it a name. But you were also saying there is a subclassification within the crust, within the mantle, and within the core. So is there also a discontinuity? Yes, certainly there is. And we have found it and we have given them a name. The discontinuity between outer crust and inner crust is, this is outer crust, this is inner crust. Its name is Conrad. Conrad discontinuity. One more discontinuity you will encounter here, just behind the, just beneath the upper mantle, which you have already studied, asthenosphere. When you come to the mantle, from upper mantle to lower mantle, when you travel from upper mantle to lower mantle, you will also encounter a discontinuity, which is rapidity. And when you go from outer core to inner core, you'll also encounter a discontinuity which is Lehman discontinuity. Now this data should always be with you. Should never forget this data. Why? Because this is the basic. And whenever you write any answer which may or which have slightest of the option of writing this data, you must draw a diagram and you write this data in your answer. In prelims, it will be given to you. Okay, there might be direct questions basis on the data, or there might not be. There might be statement, so you can easily draw your inference into the prelims questions. But here in the mains, it is your analytical part, your prerogative, whether you write this or not. And whoever writes this, whoever use more subjects in his answers, will get more marks. Must remember this data. Now, let us come to our, whether we have discussed this or not, but we have, okay, we have covered this, like why tectonics works, why there are volcanoes, why mountain building happens, why do earthquake come, why there is a rise, or why there is a phenomena of magnetism and erosion. It is indirectly related to interior part of the earth. Like there are many phenomena, like what I say, if the movement of air, the result of change in energies or the flow of earth, that causes erosion. And mountain building, what it does, it mountains are the point of origin for many rivers, and even rivers do erosion. Erosion is indirectly related to interior of earth. So this you can cover or you cannot cover. But those are last slide. Now the first question you should ask me, sir, it is good. You have told us like what is inside the earth. We have studied that. We have understood that. But your question should be, how do you came to the point like these are different layers on the earth? What are your sources? What are your sources to study the interior of earth? So the sources can be divided in two types. One might be direct sources, others are indirect sources. And you recall your memory and you'll come to know that I told you that the maximum depth to which humans have drilled earth is 12.5 kilometer. Kola Peninsula, where it is, where is this? It is in Russia, northern part of Russia. So what might be the direct sources? Direct sources might be mines, deep mines. They are very deep. Something like gold mines, diamond mines, or this drilling. These are direct sources. Other sources are volcanoes, volcano material. So these are the direct sources which help us to study the interior part of Earth. Now, what are indirect sources? So indirect sources are meteorites, then seismic waves, then gravitational force. How these help us to study interior of Earth, we shall understand. First is meteorite. So we all know a common theory that entire solar system is made up of one kind of process and one kind of material. So whenever we receive any external material, it reaches on the surface of Earth. It is called meteorite. So whenever a meteorite we take and study it, we can come to know like what the material of it. On the basis of that, we can draw inference like, okay, Earth might be made up of this kind of material. Then how gravitational force? देखो, ideally the value of gravitational force, which we write around 9.8 meter per second on the surface of Earth, should be same on the entire surface of Earth. If I say more precisely, I'm excluding the bulge of equator and the what I say bulge of equator and poles, which are which are not bulge but are somehow at less radius. So if I exclude that part, the value of gravitational force should be same at each point of Earth, but it is not. It is different. It is, and the difference is not much, but very slight, very slight. So why this happens? It is happening because of the distribution of material. Since many part of the Earth's asthenosphere, inner core are in the liquid state, liquid or partially liquid state. Thus, this mental part it is in ductile state. So what happens is whenever the impact of the convection currents are felt in these parts, the distribution of the heavy material changes, and due to that change, you can draw inference like something is something is in the liquid state. Okay, and that change, the gravitational force is being changed that particular part. Let me explain you very easily this part. Let's presume this is Earth or mental. Now let's presume entire Earth made up of a single constituent or single material or single type of materials. Okay, and those materials are stationary since the beginning of the Earth. If this is the condition, the value of gravitational force, let's presume it is 9.812132.5. This is not correct, but I am writing it just to explain you this part. If something is as it was on the beginning of Earth or at the time of formation of Earth, this value should be the same each and every day. But no, this is not the case. What happens is this part is in the liquid state. So iron or any other material which is a heavy material which get redistributed from this part to this part. Here the impact of the convection currents are felt, and since it is ductile, it is being T-shaped like this one. Asthenosphere, which is in the liquid state, again redistribution of material takes place, and material goes from this point to this point, this point to this point. So due to this impact, the value of gravitational force at this point might be 4. If this change is taking place, you can say something is being redistributed inside the Earth. Therefore, gravitational force is changing. One more point: if everything is same and stationary, and there isn't any change, the value of gravitational force should be same here, and here. Or if we even include the impact of bulge of the equator, the value at each latitude, sorry, value of gravitational force at each latitude will be should be the same. But this is not the case. Whenever redistribution of the material takes place inside of the Earth, the value of gravitational forces changes. So therefore we can say yes, there is something, some changes, there are some changes taking place inside of the Earth, and therefore gravitational force is changing, and it might be it might not might be, it is a source of study for us. Now seismic waves, these are the most authentic source. Seismic waves are the most authentic source to study interior of the earth. How? Let's say, what are the seismic waves? Seismic waves are the energy. These are the energy which is released due to the impact of any earthquake. Wherever, whenever any earthquake comes, it releases energy, and energy is being released in the form of seismic waves. So earthquake comes at a point which is called hypocenter. You all know that hypocenter is the original point or original center where the earthquake originates, or the earthquake comes at the first time. Now, directly perpendicular to this point, there is a point called epicenter. Epicenter is the point on the surface of the earth where impact of the tremor or impact of the earthquake is felt first. Remember these 2 points just for your knowledge and understand our further slides. So what happens whenever any earthquake comes? There are type of waves which are being released. First is body waves. Other one are surface waves. Now whenever I'm writing this in plural, so there are certainly more than one type of waves. Yes, E waves, write it like that. E waves and S waves. For your information or for your knowledge, I'll write L waves only. These are also two type: curve waves, relay waves. But we need to not need to go such depth study these. Shall stick to this only. L wave. From this point or from this name, you must know that the body waves, these are the energy waves, or these are the energy or the waves which travel in the body only, and these are the waves which are the result of the transfer of energy or the transformation of the energy on the surface only. Or in simple words, if earthquake is coming at that point, this is the hypocenter, body waves will be to this part, from this part to this part, or this part or this part, like that. These will not be felt on the surface, therefore they are named as body waves. Surface waves, what they are, they will not be felt in the body of earth or interior of earth, they will be felt on the surface of earth, therefore they are named the surface waves. So P waves, these are the fastest of all waves. They are longitudinal waves, and they may travel in any medium, whether it is a solid, may travel in any medium, but their speed will be different in different mediums. They'll be fastest solid, then liquid, then gas. Okay. Now comes the S waves. They are slower than P waves. If they are longitudinal, they are transverse, and they travel only and only in solid part. So from these waves, we draw an inference or we come to a conclusion that certain part of the earth is in the liquid state. Therefore, we are not able to observe these waves, these S waves on that part. Okay, let me. Okay, we shall draw that different. We shall draw that later, or we'll do it right here only. Let Let us say this is the epicenter of Earth. Okay, the hypocenter. Now forget this for a moment. Just focus on epicenter. What shall happen from this part? From this part, let's draw. Just write it here. So you'll get a better understanding. From hypocenter, P waves, S waves, and L waves, they are sent in the entire, in all the directions, in the entire part of Earth. It is not like that, that these waves should be sent only in the perpendicular direction. No, not like that. They'll be sent in all directions. They'll be sent in this direction, in this direction, in this direction, in this direction, in this direction. The point we feel the impact of earthquake at epicenter is because this is the shortest distance from the hypocenter. Therefore, the waves reaches it, most reaches to this point fastest, and we felt the impact first. Now to hypocenter, the waves are sent in all parts of the earth. What happens is wave will be sent to this part, 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 like that only. S wave will be sent to this part, S, S, and S. Okay, so we take a seismograph and we observe S and P waves here. They should be present here, S and P. If we take a seismograph and take it to this part of the earth, S and P waves should be there. These should be there. These should be there, or any part of the surface. Okay, this should be the case. This is not the case. This should be the case. But what happens is, since the S waves cannot travel into the liquid state, so what happens is, if I take the epicenter from here, 103 degree, here 103 degree. So you'll find S waves only in this part only. And we know that S waves cannot travel from the liquid part. So from there we drew an inference that some part of Earth is in the liquid state, since oh sorry, some part of the Earth is in liquid state. Henceforth, S waves are not traveling to that part and are absent from that part or beyond that part. Some part is in the liquid state, which is here, that is stopping S waves from traversing, and this entire zone will be called S wave shadow zone. Okay, what about P waves? Again, through a center, what happens is, you know that speed of the P waves are different in different mediums. They are fastest in solid, then liquid, then gas. One more thing is there, their path is deflected when they travel from one medium to another medium. Similarly, like light waves, we have already seen in our small classes or our early classes, the refraction and reflection of the light. The same happens with the P waves or with the S waves also. Whenever they travel from a one density to another density, there shall be reflection, sorry, there shall be felt a refraction. Same happens with the P waves. When they travel from this part, again, the zone of 03 degree epicenter to 103 degree epicenter, shall see P waves. Then comes to the liquid part, the earth. Now what will happen? P waves which were traveling in straight path or slightly moving path, but not very destructive path. What happen when they encounter a liquid state? Their part, I mean, they will feel a huge refraction and their path will change. Now what we will see, they'll travel to this part, liquid part, again come to the solid part. Thing like this will happen. And this zone will not experience or will not see any P waves shadow zone. We have already seen S wave shadow zone which was beyond 103 degree from epicenter. The P wave shadow zone will be from 103 degree 140 degree or 142 degree. Find different ranges in different books. So in this range you will not find any P wave. The reason is very clear or very easy, that due to change in density and the state of the material or state of the interior of the earth, P waves refract from their original path and are being absent, sorry, not are being absent, are absent at certain location or certain point, certain area on the surface of earth, that will be called P wave shadow zone. And after what will happen after this 140 degree? You will experience P waves here, from here to this part. You will experience P waves here. So this is not the P wave shadow zone. So if it is asked from you in your exams, what is S wave shadow zone? You will say this part. Anything that is beyond 103 degree is S wave shadow zone. What is P wave shadow zone? The part that is between 103 degree to 140 degree is P wave shadow zone. And if it is not asked like S wave shadow zone, P wave shadow zone, what is it? If something is asked like that, what is shadow zone, then you have to focus on that part only. This is the shadow zone where you will not experience or feel any wave. Okay. Then for next line, what are longitudinal waves? What are transfer waves? So P waves is P waves. I'm talking in perspective of, they travel in a line. What are waves? These are the transmission of energy only. And whenever the transmission of energy is taking place, the particles of the medium, they vibrate either in the direction of the travel or in the opposite direction of the travel, something like sound waves, like sound waves. So the particles of the medium will show a movement either in the direction of the propagation or in the opposite direction. If they, I mean, it is called compression and rarefaction. Compression, when they come together, particles when they come together, it is called compression, and rarefaction, when they expand, it is called rarefaction. So the, it is very simple, the movement or the vibration of the particles will be in the form of compression and rarefaction. What is transfer waves? When the vibration of the particles of the medium takes place at the perpendicular of the propagation of wave. This transverse wave transmission, transverse wave transmission, the particles of the medium will vibrate perpendicular to the direction of propagation of wave. Suppose if wave is propagating in this direction, the particles will vibrate perpendicular to that. Therefore, this is the reason P waves are faster, because the particles are moving in the same direction, and here particles are moving in the perpendicular direction. Then comes the L waves. These are the surface waves. These are the waves which brings destruction. The surface of earth. These are transverse waves only. These are slowest among all. Okay, and look, I remember a statement or a question which was asked in 2023 exam, 2023 UPSC prelims. Unfortunately, this is not with me right now, but I remember the question was like there are different waves in the earthquake, and yes, it was correct. And the next question was P waves are faster than S waves or L waves. Obviously, that was correct also. And the third statement, there was a third statement also that I don't remember right now. So on the basis of that or your knowledge, you can come to conclusion to your questions or answers. Or if question is not objective, have to write or draw. You have to write the information and particularly terms or draw the diagrams in your subjective answer. Okay, so this was a topic. I shall I shall repeat it for your revision. So when we study interior of Earth, this classification has become obsolete. Sial, Sima, and Nife wala. We don't study it right anymore. Earth has three layers. The outermost layer is crust, on which I am standing, you are standing, and our houses are built. Below that, the layer is mantle layer, and mantle layer has two parts: upper mantle, lower mantle. Below that, the part is core layer. The depth of crust is from our surface to 100 kilometers at some places. Depth of mantle is around 2900 kilometer, both including upper and lower. And the core part of Earth goes from 2900 kilometer to center of the Earth, which is around 6400 kilometer. Okay. The crust is the crust. Uh, the density of the crust is 2.7 gram per centimeter cube. The average density of the Earth is 5.51 gram per centimeter cube. So definitely the density of the crust is lower. That's why crust is topmost layer of the Earth. Then there are two parts in the crust. The outer one is upper crust, then lower crust. Upper crust and lower crust are made up of different materials. The topmost part of the crust is made up of sedimentary material, then lower part that is made up of igneous material, igneous rocks, then basaltic rocks. What was that? That is, we have already covered. The temperature rises when we go down in the crust or down in the earth. Then main constituent of the crust is oxygen. It is not iron, but when I say in the perspective of Earth, it is iron, but not oxygen. But in crust of the Earth, it is oxygen and silicon. Okay. Then I'll come to this. I've already covered. Huh. Then what is lithosphere? Lithosphere is crust plus upper part of the mantle, which is floating over asthenosphere. This part we study in the plate tectonics, but we must know what is lithosphere since it is connected to crust and mantle, so we shall cover it here. After that, what is mantle? So mantle has again two parts. One is upper mantle and lower mantle. The discontinuity which separates crust from the mantle is which is Horowitz. The separate upper crust from the upper mantle from the lower mantle is Rapiti. and some part of the upper mantle is in partially molten state, that is called asthenosphere. Why it is in the molten state? Because we we find sorry, we drew a conclusion that radioactive material might be present here, therefore it emits enormous amount of energy, and that energy is being transformed into heat, and that heat is enough to melt rocks, therefore it is in the melting state. After that, the lower part of the mantle, I mean upper and lower part of the mantle, which are though in solid state but they are in ductile state, they are ductile, and the reason of the impact of the convection currents in the mantle is the reason of plate movement on the surface of the earth. Then comes to the core part. Core part is made up of iron and nickel. I mean, the main constituents are iron and nickel and heavy metals like that. Outer core is in the liquid state, and liquid iron, the outer core is the primary region for the generation of the magnetism of the earth. Inner core, due to enormous amount of pressure exerted on this part, is in the solid state, though it might have been in the liquid state, but since the pressure is enough to keep it in the solid state. Then we come to the point, what are our sources? So there are direct sources, there are indirect sources. Direct sources are not that much, I mean, direct sources are not not solid enough to tell us the interior of the earth. I mean, the maximum, not I mean the actual part is, the truth is that the maximum depth we have drilled is 12.5 kilometers, so we cannot from our direct observations we cannot go beyond that. And